Okay. Hi. So today we're going to talk about the Schottlyer's principle and how it affects Q versus K. So K is equilibrium constant. It equals product over reactants, but only at equilibrium. Whereas Q equals product over reactants, but it does not have to be equilibrium. So Q is equal to K. That means, yay, we're at equilibrium. Yay. When Q is greater than K, that means the reaction is product favored, shifting toward the product. That way. If less than K, it's reactant favored. It's going that way. Positive. So, for concentration, if the concentration of the reactants increases, then the reaction will need to shift toward the product to be back at equilibrium. So Q will be greater than K. Wait a minute, I think that's wrong. Cut. Okay. So for concentration, if the concentration of the reactants increases, that means that the equilibrium will become product favored and shift to make more products. So Q will be greater than K. And the reverse is true if the concentration of the products increases. For temperature, if the reaction is exothermic, heat is treated as a product. So the temperature is increased, that means that Q would be less than K because the reaction would become reactant favored. If it's endothermic, that means that heat is treated as a reactant. So if the temperature was increased there, then Q would be greater than K because it would be product favored. For pressure, if the pressure is increased, then the reaction will shift to the side that has the fewest moles of gas. So it depends on what the reactants and products are. Let's say there were 2 gas moles over here and 1 over here, and the pressure were increased, it would shift this way. So Q would be greater than K because it would be product favored. And it works just the same if the volume is decreased as it would if the pressure were increased. And if the pressure were decreased, it's the same as if the volume were increased, which means in both cases that the reaction would be reactant favored and Q would be smaller than K. If a side reaction occurs where the side reaction is with a reactant, then equilibrium will shift to be reactant favored and Q will be less than K. If it happens with one of the products, then the opposite will be true. Was that a signal or something?
No.
Oh. Okay. If a solid is added, it has no effect on the equilibrium.
No
Q will
offense.
still be equal to K. And also it's important to note that the solid will not be included in the equilibrium expression. And the same is true if an inert gas is added. That will also not affect the equilibrium, and it should also not be included in the equilibrium expression. Okay, now we're going to go through a practice problem with this information. So here's the reaction we'll be using. PCl3 plus Cl2 yields PCl5. Which way will the equilibrium shift when 1. The volume is reduced by 1/2, 2. Neon gas is added, 3. Potassium is added and reacts with the Cl2, 4, the concentration of PCl is increased, and 5, the temperature decreases. We're going to go through this one together. So for number 1, if the volume is reduced by 1/2, the reaction will shift to the side with fewer gas moles, which in this case is the product side. Therefore, the reaction will shift right. When neon gas is added, it won't change anything because neon is an inert gas and it's not going to react with anything. So, no change. When potassium is added and reacts with Cl2, it will take some of this out of the reaction that is happening here. So the reaction is going to shift left to make more Cl2, to get it back to equilibrium. So left. If the concentration of PCl3 is increased, that means that there will be too much on this side for equilibrium to be maintained. So the reaction is going to shift right. And when there's a decrease in temperature, here you have to look at whether it's endo or exothermic. Because bonds are being formed rather than broken, energy is released. And that means that heat is a product. So if the temperature is decreased, it's the same as taking some of the products out, which means that the reaction will need to shift right to make more. Cut.
Dun-dun-dun. 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 Ba-ba-dun. Dun-dun-dun.
What are you doing?
Dun-dun-dun. 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 Dun-dun. Dun-dun.
Okay, so this one you're going to do by yourself. So what you should do is pause the video for a second, and then when you unpause it, the answers will magically appear. Is this what you got? If so, good job. You learned something today.